Hello, and welcome to Lesson 4, Types and Variables. I'm Trisonius. Let's go ahead and get started and understand what we're going to learn today. So today we're going to focus on data types. Data types come in three different classifications. Some data types are value types, some data types are reference types, and some data types are pointer types. Now, pointer types are an advanced subject and one that we will probably not discuss in great length until later on in the course. But we will begin to focus on value types and reference types. But we're going to learn about all three today. We're also going to learn about variables and variable initialization. And then we're going to learn some about the console object. And we're going to write our first program today, where we are taking and storing data in variables which reside in random access memory. And then we'll use the console object to display the data that we're storing in memory onto the console. Okay, so without further ado, let's jump in. So what are data types? So data types specify the type of data that a valid C# variable can hold. So a data type does exactly as the name infers. It defines the type of data that you're going to store in memory. Now, C# is a strongly typed programming language. And what that means is that once you define the type of data that you want to store in memory, it will not allow you to store anything else in that memory location except for that type of data. And this ensures that you don't make mistakes, and this ensures it provides a level of integrity, and it provides a level of security and comfort to the programmer, because it really won't let you make a mistake in this regard. And so some people view strongly typed programming languages as being overly cumbersome. I personally prefer the security that is brought by having a strongly typed programming language. So, as we talked about, data types are divided into three categories: value types, reference types, and pointer types. We're going to go over the definition and give you a brief example of what each one of these are. And then we'll start to dig in a little bit more. Again, we're starting off walking through a definition of what all these items are, but we will be opening up Visual Studio, and I'll be walking you through how to actually use these concepts today as we begin to build our first program. So let's dig into one of these. So let's start with value types. So in C#, the value data types will directly store the variable value in random access memory reserved for a particular application known as the stack. So every application has its own memory space that's been allocated to it. And part of that memory space is known as the stack. And so the stack holds values associated with the data values themselves. So what happens is that value data types allow you to store data of a particular type directly on the stack as a value. Now, the type of data type that you want to use depends on what it is that you're trying to store. The table that you see on your screen right now is an example of what all the different native data types are that are value types. So you'll notice if you look down, I guess about the fifth, maybe sixth row down from the top, you'll see byte. So the alias is called byte, and the type name is system.byte. And so you'll notice that the size is 8 bits, and it can store a value from 0 to 255. Well, in the previous lesson, we learned about bytes. We learned about bits. So we know why a byte is 8 bits of size, and we know why it stores a value from 0 to 255, because the 8 bits each have a binary value that can be turned on or off. In your previous example, in the last lesson, your homework assignment was to figure out how large of a number you could store if you were to store 2 bytes side by side. You'll notice that there's a type for that, and it's called an unsigned short, or U short. It's also referred to as an unsigned 16-bit integer. So you'll see that a U short is system.uint16, or unsigned integer 16, and it stores a value from 0 to 65,535. If you did the homework assignment from the last lesson, you would have come up with why it can store a value from 0 to 65,535 based on any one of 16 bits being turned on or off. So as you can see, based on the type of data that you want to store, you use these particular value types or value data types. Now, most of the data types that you're looking at here are of type int or are of type long, and so these are whole numbers. So a short, a byte, a long, a U short, or unsigned short, unsigned long, unsigned integer. These are all whole numbers. They're integers, and so you can store these large values, but they have to be whole numbers. Now a float, a double, a decimal, those hold fractional values, and so you'll be able to store decimal values with those. And then the car data type, system.car, is 16 bits long, and it allows you to store a character, like an alphabet character. And then a bool, which is of type system.boolean, allows you to store a value of true or false, or on or off. Okay, so these are the value types, data types that are available to us when we use C#. For the most part, you will use byte, integer, and probably double and bool the most. Those will probably be the 4 most value types that you use, but all of them are available to you. Okay, so let's move on. Let's talk about reference types. So reference data types will contain a memory address of a variable value, because the reference types won't store the variable value directly in the stack, but rather in another area of memory known as the heap. So what happens is that you may have some kind of data that's not a single value. It may be multiple pieces of information that you have in one data type. And so that data type will get stored in memory. And then on the stack will be the memory address that points to that particular memory location where the real value is stored. So rather than storing the actual value in the stack, we actually store a reference or memory location to the real value. And so this is known as a reference type. So the value itself is not on the stack, but instead it's in the heap. And then the address to that location in the heap is what is stored on the stack. And so there are 2 native C# reference types that are available. One is known as a string. And a string is used to hold text, right? It's the type used to store text. Pretty much everything that we looked at from a value type perspective held a number. But a string holds text, and it represents a sequence of Unicode characters. And it comes from the actual type system.string. The other reference type is object. And so, interestingly enough, in C#, all types, predefined and user-defined, reference types and value types, inherit directly or indirectly from system.object. So the reference type object is basically a base class for all other data types. So everything really inherits from system.object. We'll get into that more. We'll talk about what objects are more as we move forward. But it's important that you know that these are the two basic reference types. In fact, as we begin to write code, we'll learn how to create our own types of classes that can be reference types. We'll also learn how to create our own type of objects that can be value types. So we can create objects that are reference types and objects that are value types. But we'll get to that in a later class. Let's continue to move forward. The last type of data type classification is known as a pointer type. And the pointer data types will contain a memory address of the variable value, very much like what we talked about from a reference perspective. However, you can begin to access the memory location directly in the heap. And so you can have a pointer that points directly to it, and then you can begin to manipulate the pointer. And you can manipulate, pointer manipulation can happen in two different ways. You can use an ampersand, and it's known as an address operator, and it's used to determine the address of an actual variable. And then you can use an asterisk, also known as an indirection operator, and it's used to access the value of an address. So we'll talk about those things a little later. Pointer types are somewhat similar to reference types, but there's a slight difference. A pointer type is a reference type. There's a slight difference. Anyway, this is a more advanced topic like we talked about. It'll be covered more later. It's only included for completeness, and it will not be revisited until later in the course. Okay. So now that we understand that data types represent the type of data that we want to store in memory, let's talk about variables. A variable is nothing but a name made up by a programmer that references a place in memory where a particular value of a data type is stored. So if we grab a data type and we're allowed to assign data to a data type, we know that it's either going to go into the stack if it's a value type, or it's going to go onto the heap if it's a reference type. And we would have to know the exact memory location where that was stored if we wanted to be able to access it. Luckily, we don't have to know that. Instead, we are able to create variables. And a variable allows us to associate a name with a data type and its corresponding memory location. So anytime that we reference the name, which is known as a variable, we're actually referencing the data type and the value associated with that. So what we do is we have to declare these variables in programming. So variables must be declared using the following format. We first type in the data type that we want this particular variable to be associated with. Then we can type a space. Then we type in the name of the variable. And every line of code that we type in, that's us. When we're through with the series of instructions associated with that line, we end it with a semicolon, and that tells the compiler and the computer that we are through with that line of code. So every time we want to end a series of instructions to the computer, we need to end it with a semicolon. So there's only a few exceptions as to when a semicolon is not used, and one of those are what we call a code block, and we'll get into that a little bit later. So a data type, so the format is data type space variable name. The data type must be a valid data type, reference type, or pointer type. So, and we went over what those are previously. Again, very high level. Don't expect you to understand all that or remember all that, but it'll make more sense as we move forward. And then, so we put the data type in, and then a space, and then the variable name. And that's a name that you define that must not begin with a number. So a variable name cannot start with a number, and it cannot contain special characters or spaces, with the exception of an underscore. It can contain an underscore, but that's it. It can't contain spaces. It can't contain an @ symbol. It can't contain a pound or a splat, or it can't have any special characters in it at all. And it's best practice that the name should be representative of the data that's going to be stored in memory. So for instance, if we wanted to declare or create a variable that was of type integer, and it was going to represent or hold someone's age, then we'd probably want to call it or name it age. That way, any programmer looking at that name understands what data we're trying to represent with that variable. So variables are an easy way for programmers to reference memory locations by a name rather than having to remember or figure out what the memory address is. And when a variable is declared, it will most often require a value to be stored within it. So the first time we store a value into a variable, it's known as initializing the variable. It's also known as variable initialization, or simply initialization. Down at the bottom of the screen, you'll see that there are two variables that have been declared and initialized. The first variable is of type int. So its data type is int, meaning it will store a numeric value of type integer. In fact, int will store a data value of type system.int32. So here we're declaring a variable of type int, and we've named it age. And then we've initialized it with a value of 26. Now the equal sign is known as an assignment operator. So a single equal sign is known as an assignment operator. And anytime you ever see a single equal sign, the easy thing to remember is you're going to take whatever the value is on the right-hand side of the equal sign, and you're going to assign it to whatever's on the left-hand side of the equal sign. Also, it's important to know this. Computers read right to left. Humans, at least in English, we read left to right. There are some languages that do read right to left as well, but computers definitely read right to left. So the way the computer reads this is take that value 26 and assign it to the variable named age, which is of data type integer. And so because data type integer is numeric and it will store a whole number, C# is strongly typed. It will allow the number 26 to be placed into that variable. So that's a valid line of code. And we put a semicolon at the end of it to tell the compiler that, hey, this instruction is complete. You can move on. The next line, we're declaring a variable called name. It's of data type string. And remember, string is used to hold text. And so we're going to store or initialize this variable with the name Tresonius. Anytime that we want to represent text, text must appear inside of quotation marks. Numbers do not. And again, remember, it reads right to left. So here we're saying, okay, take the value Tresonius, assign it to the variable name, and the variable name will only accept data that's of type string. Tresonius is text, therefore it matches with data type string, so it will be allowed. So I hope that makes sense. So let's move forward and we'll talk about the console object. So the console object is a collection of code that allows you, the programmer, to write data to the console. You can write to the console without a carriage return by using console.write. I'll give you an example of this in a second. And you can write to the console using a carriage return by using console.writeLine. So the difference between console.write and console.writeLine is if I use console.write, it's going to display something on the console, but it's not going to go to the next line. There'll be no carriage return. But if I use console.writeLine, it will display something onto the console and then move to the next line as though you would hit the enter key. It would move down. Now there's a lot more features that are part and offered through the console object, but we're only going to focus on these for this lesson. Okay? All right, we're going to go ahead and open up Visual Studio, and we're going to dive in, and let's put all this into practice. Okay, bear with me for one moment while I open Visual Studio. Okay, let's go ahead and open up Visual Studio. I'm going to just click on this. You'll see Visual Studio open up. Hopefully you can see that on my screen. Everything's working and looking okay. And then what I want to do is I want to choose Console Application .NET Framework. So I'm going to highlight that, and it's going to open up this window. Now, if it doesn't show Console app here, you can just click on the Create New Project, go up to Visual C# and find Console app and the .NET Framework from the list. Let's go ahead and put let's put a name for our project. I'm going to name it Console Character. And you know what? Actually, let's name this Console Lesson 4. Now, this next line is the location where it's going to be stored on our hard drive. Now, I'm going to store mine on the C drive under the Users folder, under a Source folder, Repos. What it's going to do is it's going to go create a new folder under Repos called, or by the name of Console Lesson 4. And down here, we can target what version of the .NET Framework that we want to go for. And I want to target 4.6.1. So please do the same. All right, so if we click OK, and by the way, I'll leave this checked because I want it to create the directory for the solution under here. If I unchecked that, it wouldn't create a folder by the name of Console Lesson 4, but I want it to use this as the folder name. So I'm going to go ahead and click OK, and this is going to go and get our development environment up and running and ready to go. And so here we go. So welcome to Visual Studio. Now you may not be able to see this very well on my screen, so I'm going to zoom this in just a little bit for you so you can see just a little bit better. There we go. I hope that helps. All right. Now at the top of our screen up here, I'll highlight this. These are known as imported namespaces. And you import a namespace by using the using keyword. We're not going to focus on that right now. This will be the topic of another lesson. But I just wanted to make sure I pointed that out. Every time that we write a new application or create a new file, it will have a namespace. And by default, that namespace will be the name of our solution. So when we created our new project called Console Lesson 4, that by default became the name of the solution, it became the name of the project, and it became our default namespace name. Again, we'll talk about namespaces in greater detail later. Because C# is an object-oriented language, all code, for the most part, exists within objects. And so the way that we create objects in C# is by programming using classes. And so here you'll see that there is a class by the name of program. And inside of class by the name of program, there is a method or a function, which is called static void main. And so every single application that we write will always have an entry point, so the computer knows exactly where to start the application whenever you double click on it for it to run, or you invoke it from the command line. And by default, the name of that starting point is main. And so what I want you to do, we'll get into all this stuff later. These brackets indicate the opening of a block and the closing of a block. Sometimes this is referred to as a closure. So all this is really saying is that anything in between these brackets belongs to in the namespace, or belongs to the namespace console lesson 4. Anything in between these two brackets here belongs to the class program, and anything in between these two brackets belongs to this particular method or function, static void main. I want you to put your mouse cursor and click the left button behind the first bracket and hit enter so that we can create a little bit of space. The first thing we're going to do is we're going to declare a variable of data type string. Remember, this will be a reference type. It doesn't matter. The computer handles reference types and value types for you, but there are certain things you can do later on with advanced techniques that you'll want to know what the differences are. So that's why I introduced the concept early. But just note the computer handles that for you right now. So here's what I want you to do, or really and truly the .NET framework handles that for you. But let's declare a variable of type string to hold a name. So what we're going to do is we're just going to type in the word string. So we're telling the compiler at this point in time, hey, we're declaring a variable, and its data type is string, meaning that it can be used to store text in memory. So space, and then we get to name our variable. I'm just going to name it name. Okay, so string name, and then semicolon. We'll just end it right there. That's the end of that instruction. So what that has told the computer or the compiler to do is to go and reserve memory to hold text, and we want to refer to that memory location by our variable name, which is just simply name. Now let's go and declare another variable, this time of type integer, and let's make the variable name age, and then hit semicolon. And so that's great. We have string, we have a variable, we have a variable named name of type string, and a variable declared named age of type integer. Now we can assign values to these variables. By assigning values to these variables, we're actually sticking these values in memory. So for instance, we could type name equals, and because it's text, it needs to be in quotation marks, Trisonius. Now I'm putting Trisonius here, but I encourage you to put, whatever name you want as you go through this. And then age, let's say 27. That's not my age, but we'll go with that. And so these lines up here declared the variables. So they declared and told the .NET framework and the compiler and the computer, hey, reserve this memory. And for this type of data by these variable names. And then down here, we're able to actually store those variable names. Now remember whenever I told you that C# was a type-safe language, strongly typed? What that means is that it knows that this is text, and because we've declared this variable as string, it knows that we can assign text to this variable. Let me show you something. Visual Studio and C# is very powerful. Let's just say we tried to put the number 27 in there. Okay, you see that red squiggly line? it already knows that's not going to work. It's already evaluated that for us. And if we hover over that, it tells us that cannot implicitly convert type integer to string. So we're trying to store an integer value into a variable that was defined for string. It won't let you do it. So it really helps you. Goodness, can't even spell my own name. All right. So now that we have these variables stored, we've actually placed them in memory. What I want to do is I want to use the console application in order to write these to the screen. So what I'm going to do is I'm going to type in console.write. And by the way, when you hit dot, you'll get a list of all of the methods and properties that are available to you. Methods, think of methods as actions, and think of properties as data elements where you can further describe things. So right now we want to write something. So we can use our arrow key to go up and down the list. We can begin to type, and if we put a W, it will automatically go down. So I put WR, and it narrows it down to only those things that start with WR. And what I want to do is I just want to use write. So what I can do is I can hit the tab key right now. If I hit the tab key, it'll automatically complete that for me. And that saves you some time of having to type things out. Also, it's important to note that C# is case sensitive. So if there's a method with a capital W, lowercase r-I-T-E, then you have to spell it with a capital W. If you spell it with a lowercase w, it's not going to work. So it's case sensitive. Your variable names are case sensitive as well. So let me just come back up here real fast. If I were to declare another variable with a capital N, it would let me do that because these are seen as two totally different things. Now, if I tried to declare with a lowercase, it's going to give me an error, and it's going to say the variable name is declared but never used. Then it's going to say a local variable or function named name is already defined in the scope. So your variables need to be unique. But again, if I change it to capital letters, it sees it as unique. Okay, coming back down here, console.write. So console.wr, hit the tab key, and then anytime there's an action, you always need to use parentheses. Parentheses it's the way that C# uses to indicate a method or function. Methods and functions are used to create an action. So console.write, open parenthesis, and then inside of inside of the parentheses, I want to put quotation marks, and I want to put the word NAME space, colon, space, end, semicolon. Okay? Now what that's done is it's told, remember we're going to read from right to left, the computer is. What we've done is we've told the computer, hey, we want to take the string that is, so anything that's inside of quotation marks is text, and text is a string. So this is what's called a literal string. We're going to take this text, name, colon, or name space, colon, space. We want you to write that to the console. Okay? So what I want you to do is I want you to save this. Come up here to debug. And then go down to start without debugging. And click that. What it's going to do is it's going to compile this application. And then it's going to run it. Okay, now you'll notice that it says name space, colon, space, and then press any key. All right, so if I press any key, it'll end it. But what did I tell the computer to do? I told it to write name space, colon, space. So it did. And that's good. That's what I wanted it to do. Now I want it to write something else. Let's come down here, and I want it to write the value that we stored in memory for name. So for me, it's going to be Trisonius. So I'm going to type in console dot, and I'm going to go to write again, except this time I'm going to go to write line. I'm going to hit tab. By the way, you can spell it out yourself. So write line and then hit tab, and it'll automatically correct the case for you. Because again, it's case sensitive. So this time I want it to write out the value that I have in that variable, in that memory location. So I'm just going to put name. So if I just put name there, like I did here, it knows that name is a string. How does it know that name's a string? Because I defined it here. And guess what? You know that green squiggly line that we had under it? It's gone away because now we're using that variable. So what we're telling is go use the variable name. Well, by us using name, we're really saying go to the memory location that we reserved for name, get the value out, and replace the variable name with the actual value. Then use that to write a line to the console. And remember, when we write a line to the console, that means that we're going to write this out to the screen. And because it's a write line, it's going to hit enter afterwards. So if we save this again, and we go up to debug, start without debugging, we're going to notice that now it says name : Trisonius. And it went to the next line because we used write line instead of write. Does that make sense? I hope so. All right, let's do another one. Let's do the same thing with age. Let's type in console.write, open parenthesis. This we want it to be literal. So we're going to put age. I'm going to put 2 spaces so it lines up with name. And then in the instruction. And then console.writeLine, oops, open parenthesis, and I want to actually have it write the value that's in the variable age. And so now, if we save this, we go to debug, start without debugging, name Trisonius, age 27. That's fantastic. And we can create blank lines as well. All we have to do is just simply type in console.writeLine, open parenthesis, close parenthesis. If we don't pass anything between the parentheses, it'll just do a carriage return. Okay, so we'll be able to see that if we hit build, debug, start without debugging, name Trisonius, age 27, then it skips a line, then it's press any key to continue. Okay, see, not hard, guys, not hard at all. So here you've learned how to declare variables. You declared a variable of type string that you called name, declared a variable of type integer that you called age. You then assigned the value Trisonius to the name variable, and you assigned the value 27 to the age variable. Then you use the console application to write those out to the screen. Great job, guys. Fantastic job. I hope you learned some. If you have questions, if there's anything that you don't understand, just post those questions in the bottom below the video in the notes, and I'll do my best to answer them. Okay. Lesson review. So in this lesson, we learned that C# is a strongly typed language. We also learned that data types define the type of data that can be stored in memory and how much memory will be required to store it, because we know how many bits are required in order to store those particular values. So data types are divided into 3 different categories: value types, reference types, and pointer types. Again, pointer types are more of an advanced concept, and we'll get into those later. Right now, we're primarily focused on value types, but we will be getting into reference types in the next couple of classes. Well, that's not entirely true, because we have been using strings, and strings are a reference type. But you haven't really began to see the power of reference types yet, but you will. coming soon. Now, a variable, we learned, is nothing more but a name made up by a programmer that references a place in memory where a particular value of a data type is stored. Variables can be assigned values as long as the value is the same type as the data type used to define the variable. Also, defining a variable is known as declaring the variable or variable declaration. And finally, assigning the first value to a variable is known as initializing the variable. So we've learned quite a bit. We wrote our first program. You did very well if you followed along. Now, in order to help reinforce some of these ideas, there is an assignment that I'd like to add to the end of this. So go ahead and add 2 more variables to the program that we wrote. So add a variable of type int named strength, and then add a variable of type int named dexterity. Assign a numeric value to both, very similar to the way we did before. And then use the console object to display the variable values on the screen. You know, we've already done this, so look at the way we did it before and kind of use that same process to complete this assignment. Okay, well listen, thanks for sticking with me. I hope you learned, and I hope you enjoyed this. And until next time, Personius signing off.